Hello guys, welcome to my compiler series. In this video, we are going to see what are all the phases of compiler. The compiler works in multiple well-defined phases. Each phase performs a specific task and passes output to the next phase. So let's first see the flow diagram, which is present here. Uh, First, when we write any high-level language, we generate this. For example, we have position equal to initial plus rate into 60. Then first we will pass this to lexical analyzer, which converts each and every character into token. For example, it gives ID1 to position equal to, then the second next token is ID equal to 2, which is given to initial, then plus के लिए one ID, then rate ID3, then into equal to one token, then 60. So it will generate total of 1, 2, 3, 4, 5, 6, 7, 7 tokens. Okay. Then it will then pass to syntax analyzer. The main task of syntax analyzer is to check it grammatically and gives error if it is not following any rule of grammar, which can be seen, which is properly checked by CFG. We will going to learn about CFG in Unit 2, that is context-free grammars. Then in next phase, it passes to semantic analyzer, which semantically checks the code, and then it passes to intermediate code generator, which generates the code which is independent of machine language code and also uh, understandable by the compiler. Okay, so this basically creates three address code, and then in the code optimizer level, it optimizes the three address code generated by the intermediate code generator, and then at last in the code generator, it generates the machine language code which is understood by the machine. Okay, so let's see all these phases of compiler in detail. So like we have seen that we have lexical analysis. It converts the characters into tokens. It removes white spaces and comments. It also uses regular expressions. For example, if it has int sum equal to a plus b, then the tokens will be first int, then sum, then equal to, then a, then plus, then b, then this semicolon. Then the total number of tokens here is 1, 2, 3, 4, 5, 6, 7. 7 number of tokens will be generated by this. Okay. So then in the syntax analysis phase, or we can say that parsing phase, it checks the grammatical structure and then it builds parse tree and or syntax tree. Then it uses the context-free grammars. Okay. So it's basically it creates the parse tree or syntax tree and checks the grammar it is correct or not. For example, if a plus b into c, parser checks operator precedence and associativity also. In semantic analysis, it checks the meaning of the program, uh, type checking whether if in-text equal if it is given that in-text. Then we have example here, right? So if we write x equal to hello in downwards, then it gives type mismatch error. Because if we want to write any name inside this or any uh, string of characters, then we have to initiate x with the string type, not integer. It will only take integer. Okay. So then it also provides scope resolution. It ensures variables are declared before use. Okay. So if some let's say if we write something in C, but it is not declared in above, and then it also gives type mismatch error, syntax error. Okay. Then in intermediate code generation, it converts the source program into independent intermediate code. For example, three address code, which is T1 equal to B into C, then T2 equal to A plus T1, which matlab it gives A plus B into C. So T2 stores A plus B into C. But if we write T2 equal to this directly, then it is not three address code. Three address code means 1, 2, 3. So it should contain three uh, three addresses only. Okay. Then in code optimization phase, it improves in performance. It reduces execution time and memory usage. For example, if anything is extra here, then we need to remove this. For example, if we have x equal to x plus 0, then it should be removed. X plus 0 is x only, na? So we don't need to write this. So these type of code reduction is performed in code optimization phase. It do not change the program meaning, but it improves its execution by removing any these type of redundant code. Okay. Then in code generation, it converts optimized intermediate code into machine code. It is target dependent phase. Target dependent phase means key it's basically converts the upper code to machine language code, which is understood by the machine, which for example giving registers to it, and uh, is in the form of digital logic, that is 0 1 etc. Okay. Then we also have one important topic which sometimes asked in the paper, that is compiler construction tools. These tools helps in automatic compiler development. Okay. So some of the major tools are, that is Lex. It is used to generate lexical analyzer. It is based on regular expressions. We will see regular what is regular expression, what is CFG in later unit, but let's focus on what are the tools and what did they do. Okay. So in second we have YACC and Bison, which is used for syntax analysis. Okay, it generates parser from grammar. Then we have syntax tree generators, which is used for uh, abstract syntax tree construction. Okay. So in the next video, we will going to see what the lexical analysis is and the most important and always asked question on tokens. We will see in the next video. Okay.